All right, so today we're going to talk about solving inequalities. All right, so you may ask, first of all, what is an equality? Or what does an equality do? An inequality compares two quantities. Okay, and how does it do that? So we're going to have symbols and we're going to have what they mean, okay? So on this side, we're going to have the symbols. And then we're going to have their meaning. All right, so let's say, for example, we have, I'm going to put less than like this, okay? So when you see the pointy part of the symbol is pointing to your number, whatever the number may be, that's meaning less than. Sorry. Okay. When you have it where the opening to the symbol is going towards your number is greater than. All right, let's say, for example, the line underneath that's saying less than or equal to. Okay, but when it's this way and you guessed it, greater than or equal to. Okay, great. So let's do some examples. Okay, so now we're gonna say if we have x examples. So let's say, for example, we have x, number 1, and I ask you to tell me what does this mean based on the symbols used. This means that x is greater than 4. That's right. So that can be 5, 6, 7, 8, 9, 10, so on. 5, 6, 7, 8, 9, put dot, 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 for so on. Okay? If we have x greater than or equal to, less than or equal to, this means, because remember the pointy is to this. So back in the day, they teach us that this is the fish's mouth, right? So of course the fish will want to eat whatever is bigger. So this means because the fish's mouth is open this way, the fish will want to eat 8, so 8 is bigger than. So this is saying that x is less than or equal to 8. Okay, so that means what? X could possibly be 8, 7, 6, 5, dot, dot, dot. Okay, because it says less than or equal to. Okay, so let's leave it there for now. We're going to go on to solving inequalities. So typically you treat it, and when you're solving inequalities or when you're asked to solve inequalities, you treat it as if it is an equal sign. Okay, so the same way how we learn to solve equations, you treat it the same way. Just treat the sign like it is an equal sign, the given sign that is. So let's do some examples. Okay, so number 3. And of course, the instruction for all is solve. All right, so let's say we have x plus 5 is greater than 12 to solve for x. So like I said, we treat it like we would any other equation. So again, we want to isolate the x on one side of the sign by itself. So we do that by removing everything else. And so right now we only have the plus 5 with the x on this side of the sign. So you're going to remove that. So again, we can do that by 1, subtracting 5 from both sides of the equal sign, or of the sign, or move the 5 to the other side of the sign and just change the operation. So I'm going to do the second one. So I'm going to get x is greater than 12 minus 5, and therefore x is greater than 7. So now that means that the value for x can either be 8, 9, 10, 11, 12, so on and so forth. Okay, so let's do the next one. Let's say, for example, we have 6x is less than 24. Okay, again, you want to isolate x by itself. So because right now it's multiplying, we have to divide to move it. So we say x is is less than 24 over 6. So x is less than 6. So that means x can be 5, 4, 3, 2, 1, so forth, and so on. All right, and it's the same thing with the less than or equal than sign. Let's say, for example, we had here, let's say we have x plus 10 is equal to 30. Again, treat this like it was the equal sign. So x is greater than or equal to 30 minus 10, and so x is greater than or equal to 20. Okay, same thing. 4y, let's make it tricky this time, minus 3, or more difficult. Let's see, let's say 25. Okay, so again, 4y, 25 plus 3, 4y, then you bring it down, 28, y, 28 over 4, y, 7. Okay, so again, just treat it like it was an equal sign and isolate the variable that you're told to solve for. All right, so someone may ask, is there any way we can reverse the inequality sign? So the answer is yes. I'm going to show you how or what instances you can do that in. So anytime we divide by a negative number, that is when we change the sign. So I think around 7. So let's say, for example, we have negative 5x 10. Of course, we're gonna isolate the x by itself. So we're gonna remove this negative 5. Right now it's multiplying, so the opposite would be division. So we end up with x 10 over negative 5. And so because we're dividing by a negative number, this now flips, and that's your answer. Okay, makes sense? Let's switch it to the other way. Let's say we had, let's do negative 10. Okay, let's do this. Negative 10. Let's do plus 10x (20). Let's go with minus 2x. Let's make it quick. Again, we're gonna group all like terms. So we would, I didn't do this one right, that's fine though. this is practicing, we would have sin x 20 plus 10 minus 2x sin x plus 2x 20 plus 10, again step by step, and so this would be 12x 30, and then this would be x 30 divided by 12. I think that should be 2.5 is your answer. So let's switch the signs this time. So let's say now we had, for example, 10 minus 10x minus 20 plus 2x. Again, you want to group all like terms. And so let's now say, did I do it wrong again? I think I did. Let's do it so it works the way you want it to work. So let's say now, yeah, minus 2x is equal to minus 20 plus 10. And so we would have minus 12x. Guess it. This is actually supposed to be a minus because my 10 is going from this side to this side. This will now be minus 30. And then we would have x minus 30 over minus 12. I'm not sure. Okay. And hope this would change, and the answer would be the same thing. 2.5. I have to check this one just to make sure that that's correct. And so those are the cases. So when we divide by a negative number, that is when the inequality sign would change. So now we're going to talk about graphing inequalities. All right, so we use an open circle. Sorry for background noise. When graphing greater than or less than, we use an open circle. And then when graphing or, we use a closed circle. Okay, great. So let's do some examples. So let's now say I give you an equality, any given equality, and I say, okay, graph the following. That's the instruction. Okay, and I say x is greater than or equal to 4, right? So we put 4 because it's greater than or equal to. We use the closed circle, and of course on the number line we know that if it's greater, it'll go to the right. Okay, does that make sense? And then let's say we say x is less than, it would be again 4. And of course, you know, last time we go into the left. Okay, great.